Hi, I am Ramnath S. Mani, Managing Director, Automation Excellence, based out of Chennai in India. I have been connected with the automation industry in India since the early 70s and has seen development of the industry through the decades with manufacturing plants and process industries. I was part of the founding team of Allen Bradley operation in India when it first came to India with its PLCs sometime in 1985. Subsequently, I had a joint venture with Emerson Industrial Automation in the name of Control Techniques India. Subsequently, I spent some time in an IT industry in India operating for an American company where I could understand the power of IT. Now I am the Managing Director of Automation Excellence, specializing in IT in manufacturing, including SCADA, MES, IIoT, and Industry 4.0 solutions. We are premier integrators of inductive automation. In today's topic, I am going to present a simple approach to Industry 4.0, its principles, the components involved, which include elements of both OT and IT, and the ignition platform. Before we move on to Industry 4.0, let us understand what is Industry 4.0 other than the known definition that it is the fourth industrial revolution. Industrial automation has always been developing since the 70s, and we've had technological changes which has made the product better and better, faster and faster, highly responsive. But the products that have already been there have always been developing on its own, in the sense that a PLC was becoming a better PLC, a DCS was becoming a better DCS, and a drive was becoming a better drive, and it was becoming digital. But they were restricted to whatever they were doing. The first breakthrough came for the manufacturing industry when IT started looking at manufacturing, and obviously from a different perspective altogether. It encompasses a number of modern technologies and many facets of enterprise and means. Communication was one of the subjects which actually strongly enhanced the IT industry in coming into manufacture. Connectivity was another very big issue, because the connectivity in those days were, for the industry as such, was based on its own protocol, which were mostly actually protocol which were very I would say proprietary, and slowly, of course, though it did become more common and standard, a lot of things were more proprietary. The cloud, security, mobility, etc., and analytics, all these actually changed the way IT started looking at industry and the way industry started looking at industry itself. As you can see in this particular diagram, you can see the factory being interconnected with all these systems. Whether it is a communication, collecting data, then actually processing the data, taking it to a different area for monitoring, etc. Therefore, all these put together formed what we know as Industry 4.0. And when you can do it for one factory, obviously it was possible to connect multiple factories to it. So that was the start of Industry 4.0 in practice. While Industry 4.0 is a vast subject encompassing lot of items, in today's topic we will cover only the area related to ignition as a platform, which will enable Industry 4.0 to be implemented easily and seamlessly. This includes the typical OT IT technologies and how they get integrated. When we talk about Industry 4.0 or Industrial Internet of Things, the first challenge that organizations encounter is the OT IT divide. On the left side of the screen, as you can see, the OT side, it's traditional factory automation or plant automation, or as we call it, industrial automation, where we have RTUs, we have drives, we have PLCs, we have DCS, and we have at the highest end a SCADA. A SCADA has always been part of the factory automation for years. And on the right side, you have the IT, which all started originally with MRP, and then the ERP came. Then in the ERP itself, Oracle, SAP, they all developed very powerful ERP systems, and they all came in as the first set. And then of course IT developed into other areas in terms of analytics, in terms of getting information, getting data, communication, security. They all started coming into play. The idea of bringing IT into industrial automation would be possible only if both can integrate, because on the OT side it was highly process driven, it was real time control, there were multiple industrial protocols. If you go into a factory, you will find many of the systems have got proprietary protocols, proprietary hardware, and actually the communication is proprietary. Of course, later days, they went into OPCs, etc., open protocol, and then they started communicating. But in the olden days, it used to be very proprietary in nature. Then of course it started with wired systems and then went on to wireless, and of course GPRS, Wi-Fi, they all came into play as the technology moved. And the IT side, it was highly data driven. There were data analytics, communication, mobility, cloud, security, they all started playing very major roles, and lot of development was going in the IT side in terms of languages, in terms of the way it communicate, in terms of scripting, etc. And therefore, when IT started looking at manufacturing, they started looking at it completely in a different angle. One of the first products that came to link OT with IT was the MES, or Manufacturing Execution System, which would collect all data from the factory level and pass it on to the IT, take all data from the IT, pass it on to the factory, so connecting the enterprise with plant automation. So that was the idea of bringing seamlessly the OT and IT together. But unfortunately, there has always been the divide between the OT and IT because of completely different technologies, the way they looked at the manufacturing. In times, actually they have all changed. Now I think the OT understands the importance of IT, and the IT understands the complications that are involved in the OT. So this has been going on for a couple of years, and I think we have now reached a stage where I would say the OT IT divide has come to a minimum. Industry 4.0 or IIoT is a fairly new concept for industries, and it is presenting a huge opportunity for them to thrive in this digital transformational world. But transformation is not going to be very easy. It seems easy in theory, but IIoT deployments are challenging. Multiple operational teams and business units apart from IT teams need to be involved for an effective IIoT implementation. We have to move from what we call a push economy to a pull economy. Industrial transformation obviously means different things to different people and in different organizations, but it always incorporates essential concepts, some of them which include cross-disciplinary collaboration and shop to top floor management or engagement, thoughtful alignment of processes with functional groups throughout the organization, more extensive sharing of enterprise data in and beyond the enterprise, managing data device from the cloud and to the cloud, ability to use all sorts of data, structured or unstructured, advanced analytics from multiple sources including third party apps, and open and secure communication. But for all this, I think the first step is digitization. So if you want to actually get into Industry 4.0, you have to digitize, essentially because as you know that we are dealing with a lot of legacy systems. If we were to start a completely new plant and go digital, probably it would be very much easy because we could select the devices, select the base equipment, base the devices, all digital. But unfortunately, the situation is that the manufacturing capacities for every commodity is probably at its highest, and not very many new plants are coming, and most of these plants use legacy systems, and they have been there for quite some time, and therefore the use of legacy systems makes it a little more difficult, because in the legacy systems they all operate on the older protocols, proprietary to protocols, every equipment operating with its different protocols, different communication capabilities, etc. So actually, when you want to really transform, you have to understand that there are three basic elements which are involved. One is the hardware, which is at the base end, because in case of Industry 4.0, the principles are very simple. You have to collect data from somewhere and then pass it on for IT to do some processing and get you the relative outputs. So these three elements are hardware, which at the base end of the equipment or at the machine side, you have basically, whether it's a transducer, whether it's a sensor, whether it's a PLC, whether it's a drive, even whether it's a DCS, they all speak on different languages, and therefore they have all brought to a common language platform. That's a very, very important factor. So the knowledge of the main devices and the functions and operations are to be very clearly known. The protocols, connectivity, purpose, they are all to be known before you can connect the system. Therefore, the hardware is something which one should know relatively well. Next comes the software side. In the software side, you have already in the actually plant operation, you have up to a level SCADA, which you could say uses a part of software on a hardware, and then MES and IoT, which came in later after the IIoT developed, and the importance of IIoT, which is nothing but industrial IoT. Communication became a very, very important factor. Mostly open systems, language, communication, cloud, mobility, security, database management, etc. became very, very important factors in the software side. And the third element that is very important is domain knowledge. If you don't have the domain knowledge, the conversion of all data and the processing of it, you may do that, but you may not exactly know what you want out of all that data, because now you are getting a lot of data, tons of data which are coming out, but you have to know what exactly is required for your plant, for your application, and for your needs, and that comes out of decently good domain knowledge. Now let's look at the steps that needs to be taken for Industry 4.0 implementation. All the devices in the factory floor, regardless of manufacturer, seamlessly and instantly need to communicate. Obviously, in legacy systems, as we have seen, they all communicate in different protocols, different languages, different ways in which they communicate, and therefore they need to be brought to a common format understandable to the IT world as such. So this is a challenge which has been there, and obviously we need some conversion in between, which comes in the form of gateways or comes actually in the form of edge, which Ignition also actually gives, and these actually take the data in the format in which it is coming and converts it to something which the IT world understands. Now you have a lot of data coming in from the factory to give you an insight into what is going on in each of these machines and how you could probably increase the efficiency, increase the productivity by actually looking at it and taking some considered decisions. There is also big data which is coming outside the factory from the outside world, providing systems with statistics about consumer buying habits, automatically increasing production at times of the year, when data trends indicating that demand for the product will be at the highest. Therefore, all these data need to be actually collated and then used for getting the efficiency of the system. And tapped into the global data stream, the factory of the future can not only automate smart processes to meet its own internal objectives, but can anticipate opportunities and failures based on external events before they can occur. So, these are some of the factors that has to be taken into account when you talk about Industry 4.0. And obviously, if you can implement in one factory, you can implement it in many locations and then connect them together for an overall visibility. But the fundamental steps that the manufacturer has to take is, he has to get digital, he has to get automated, he has to get connected. The remote access, the remote real-time control, real-time information you have to get and actually convert it, and then of course you have to get all internet friendly tools to operate along with the system. Industrial organizations, they see the value of uniting the factory floor with the executive office, and obviously Industry 4.0 is one of the ways in which it can get done. What is very important actually here is the vision coming from the top management. Industry 4.0 cannot be implemented well unless there is a vision from the top, because Industry 4.0 by its very nature is a very vast subject and could lead you to wrong decision making if you are not very clear on your vision. Obviously, if you want to implement 4.0 in a major way, it's not an end by itself. That you take up a decision and actually do it immediately. It's a journey which you have to undertake, and it takes a little while time, and therefore the expenses involved will also be pretty high. The capital expenditure will be pretty high. If you were to implement Industry 4.0 immediately and take all of them together. Therefore, the best way would be to take step by step, and if you want to take step by step, then you must have a very clear vision of what you want. Therefore, the vision document is a very, very, very important actually aspect of any Industry 4.0 implementation. We have to ensure that the company's management, including top management, the CEO, the CFO, IT management and OT management, production or unit management people, get committed to implementation of the IT/OT convergence and actively support the initiative. The digital strategy must be driven by a clear understanding of the customer needs and the way the products relate to them. Building IIoT or Industry 4.0 from grounds up is absolutely essential. IIoT starts with plant floor and field devices, though the vision comes from the top. With Industry 4.0 being the buzzword in industry, it's easy for manufacturers to fall into the trap of believing that digitization requires complete overhaul. In contrast, taking small and strategic steps to digitize can prove more beneficial for most manufacturers. Remember that this is an evolution, not a revolution. Upgrading to Industry 4.0 in manageable steps not only allows business enough time to make well-researched and considered decisions, but also gradually introduces employees to the new technology around them. The step-by-step approach also enables manufacturers to see precisely how digitization is adding value to their processes, and by reducing complexity makes it possible to easily connect other machinery down the line, saving money and time. For an Industry 4.0 value chain, you start with the things, as we call it. Essentially they are controllers, transmitters, could be drives, could be PLCs. They give out meaningful information. This information is collected through the gateways, or as we call the edge devices, and then it is transmitted through wireless or wired communication to an integrator, or I would say a platform, and then we actually out of that we get all the information that is needed. It goes to the various formats, whether it's a desktop, whether it is a cloud, whether it is a tablet, whether it is a mobile. It is used for giving information, and the Industry 4.0 value chain starts. What is very important in Industry 4.0 is the fact that there are 6 core factors which have to be taken care of when you talk about Industry 4.0. IIoT architecture. The first one is the fundamental concept to IIoT or IT-OT convergence is to decouple the devices from the application. So this is a very important factor. Second is superior OT solution. Third is single source of truth. Fourth, plug and play functionality. Eliminate cutovers and scale with unlimited licensing. These are some of the new architecture, you would say, which is all found in Ignition, and which is why Ignition is a very, very powerful product. Bear in mind that Ignition was developed with very good knowledge of the OT, and therefore it was an IT designed in IT, but with all the know-how of OT, and therefore it could actually exactly take whatever was in the OT, it could convert it into the IT language without losing any amount of information that is needed to make it successful, and in a very easy way. So the fundamental concept of IIoT is actually what we said, decouple devices from application. Open architecture that decouples application from devices enable enterprise to get needed data without interrupting operation at plants. And the conventional system architecture, intelligent devices such as PLCs coupled to application through proprietary protocols. What it means is, in the earlier days, the devices were all actually connected directly to its application, and as a result, they were in some ways, you could say, limited by the fact that there was only a single connectivity that was happening between the devices and the application. The new architecture is to de-link them and have all of them get connected to a central source, what we call an MQTT broker, and then actually have on one side subscribe and on the other side publish. And therefore, the data that comes out from various sources, they all go into an integrated broker, and then they come out from and go to the other devices which are actually connected with it on the application side. So this is a very, very important factor in actually going into the new architecture. Then actually one provides a superior OT solution. We can talk about analytics, machine learning and AI all we want. But if the solution doesn't meet the operations needs, it's a non-starter. Therefore, actually the architecture provides you with a superior OT solution. Single source of truth. We have to make the devices the single source of truth for tag information, save thousands of man hours, and gives in enterprise a common point of verifying correct data upon which to base decisions. It's a very, very important factor, because if you don't have the single source of truth, then you might be getting a lot of information which may all be partly true, partly not true, and as a result, you may not get the correct data that you want. Plug and play. We need to have very modular, which you can just plug and play and make it useful in such a way that, whether it is you are operating with devices or with actually, HMIs, with all the products that are of previous generation or the future generations to come. They all must be able to be connected seamlessly and keep working. Therefore, generational gaps in terms of machines have to be avoided, and actually Ignition takes care of that. Eliminate cutovers. Most SCADA systems have to be deployed in one fell swoop. But if you could run an OT application in the test mode in parallel, you could eliminate cutovers and increase the migration velocity to IIoT solutions. Scale with unlimited licensing. You need the ability to scale as your project grows. That's the very nature of IIoT. You cannot connect thousands of PLCs and hundreds of thousands of sensors under the traditional methods. They don't scale, and these IIoT projects will never see the light of the day if it's done in the traditional way. These are 6 things that facilitate the convergence of OT and IT, and so that we can connect the whole enterprise and have IIoT solutions that work in the real world right now. The Ignition platform supports these features. That's why Ignition is perfect for positioning your company for IIoT, perfect for converging OT and IT, and perfect for shifting to the pull economy. It lets you pull the modules and tools you need. It's a superior OT solution that leverages proven IT technologies, and it addresses goals of open process automation, initiatives for an open, standards-based, secure and interpolable control system. As we have now seen, Ignition provides one universal platform, whether it is IIoT, SCADA or MES. I mean, it can work actually right from the SCADA level to the IIoT level without any issues. Ignition is the only IoT platform with built-in tools for creating full-featured SCADA systems. Ignition is modular, so you can easily add fully integrated software modules for building industrial applications such as SCADA, alarming, reporting software and more. With Ignition, you can connect to all your IIoT data, rapidly develop any kind of industrial application and instantly web launch clients to virtually any device without any limits. Introduction of the Perspective module very recently makes it extremely powerful and probably the only platform which can handle any type of situation in an Industry 4.0 environment. But in case of Industry 4.0, as we have seen, there are many more elements. I mean, you have to collect data. There is a hardware required to collect data. Then there is the analytical tool that is required to analyze, because Ignition provides the platform. So obviously, it's very necessary that a very proper ecosystem is created around Ignition platform. And Ignition has worked with a couple of companies and created a wonderful ecosystem around them, so that a full offering of an Industry 4.0 solution can be provided. Finally, I mean, I would say that if you look at this particular slide, you will find an entire, ecosystem of a factory. You can connect it and see that Ignition actually falls in place in practically every area, whether it's the bottommost level at the sensor and manipulating area, or at the business end and connecting them. And it has got suite of MES products through, again, one of their ecosystem partners, Apasoft. This platform actually forms a very, very powerful tool for connecting your entire factory network in one place. And when you can do it for one factory, obviously it's very easy to connect multiple factories in different locations and actually get data from all these places and actually get information in one place. I want to finally talk about two use cases, two of our clients, who are using Ignition as a platform for their Industry 4.0 initiative. One of them is a global manufacturer, 6 business units with more than 950 plants worldwide. They have a good presence in India. They have set up a Center of Excellence in India for Industry 4.0 initiative, which they drive for Asia Pacific and also other parts of the world. They made a comparative study of all software that was available, platforms that were available, and they zeroed in on Ignition. They started actually with a particular line, I would say a glass line, and they connected Ignition, and in the plant monitoring system, connecting the controller, configuring the server port, data flow, screen development, report generation, future plan to connect with other locations. And once this was successful, they tried it with other business units. In one of the business units, actually the central server was in Mumbai, and the 2 other servers were one actually in the south near Bangalore, and one in the west, and they connected them together. It's working, and therefore some of these business units, they took the pain points that were there and they actually put in Ignition in these pain point areas and got significant benefits. The second client of ours is a electronic manufacturer based in Southeast Asia, as a global manufacturer with plants in US, Asia, China, and they have 127 machines with PLCs from Allen Bradley, GE, Fanuc, and industrial PCs. They were all getting connected. They ran it on a line to find out the advantage of using ignition, and they also connected to a number of machines that are all 40 plus years old. I mean, they were not new machines, they were all legacy systems, legacy machines, and they connected it very successfully. I mean, these are some cases where ignition have been used very successfully. You have full support from ignition coming, and they operate through integrators. I mean, integrators like us, and there are many throughout the world, and specialized in domain knowledge, which is a very important factor for actually having a successful implementation. And I think with this, I would like to conclude saying that the myth of Industry 4.0, that it's very complicated and cannot be operated easily, is broken. And when you use ignition, I think you are on Industry 4.0 successfully. Thank you.